In this figure, we have two triangles, triangle AOC and triangle BOD. You have to tell whether these two triangles are congruent to each other or not. Okay, so if you concentrate on these two lines, this one straight line and this is also a straight line segment. These are two line segments. Since these two are line segments, right, can we say that this angle, that is angle AOC, triangle AOC, and this triangle, this one, that is triangle BOD, will be equal? Now if you're wondering why, because these two are vertically opposite angles. That's why I highlighted these two line segments. So this will also be 30 degrees. Okay, now focus on these two line segments, this one and this one. Okay, and then focus on this line segment, this one. It's something like this. Okay, this angle is 70 degree and this angle is 70 degree. Now clearly these two lines are being intersected by this transversal, and since these two angles are equal, right, therefore it means that these two sides will be parallel to each other, right? These two sides will be parallel to each other. Anyways, we'll not go into that. The main thing is that these two angles are actually equal. Okay, so can we find this angle? This angle, that is angle CAO, that is angle A. Now if you're wondering how, then let me tell you. The angle sum property of a triangle says what? That all the angles of a triangle will be equal to 180 degree. That is angle A plus angle C plus angle this O, angle AOC. Okay, so angle O, this will be equal to 180 degree. That is the angle sum property of a triangle. Therefore angle A plus angle C is what? 70 degree. Angle O is what? 30 degree, and this is 180 degree. So angle A will be equal to 180 degree minus 100 degree. This will give you angle A as 80 degree. So this is 80 degree. Now same thing will be done here also, right? 30, 70, therefore the same calculation, that is this angle, angle B will also be equal to 80 degree. Okay, now what's the point here? The point is clearly angle A and angle B, angle A and angle B are equal. So from 1 and 2, you will say that angle A is equal to angle B, right? Then AC is equal to side BD, right? Side BD. Side AC is 3 centimeter and side BD is also 3 centimeter. Therefore, these two sides are equal. Then this angle C is equal to angle D, 70 degree and 70 degree. Therefore, angle C is equal to angle D. From these 3, 4 and 5, you can clearly see that. Let me highlight this with some darker color, brighter color, sorry. So this is angle, this is the side, and this is the angle. Angle, side, angle property. Can you see here that it's being satisfied? This angle and this angle, this side, the including side, and this angle and this angle. That is, on the same side we have two angles that are equal. All three are equal. So three equal parts, and three equal parts, I know way that ASA is being satisfied, that is angle, side, angle, congruence criterion is being satisfied. Therefore, yes, triangle AOC is congruent to triangle BOD. Let's move to another problem, and this is given below are measurements of some parts of two triangles. Examine whether the two triangles are congruent or not. Triangle DEF and triangle PQR, and these are the two parts. In such problems, it's always best practice to draw a rough diagram. Do not bother about these values, simply draw a rough diagram. So let's say that this is triangle DEF, and this is triangle PQR. Okay, this angle D is, in this case, the first one is 60 degree, angle F is 80 degree, and DF is 5 centimeter. Okay, then angle Q is 60 degree, angle R is equal to 80 degree, and QR is equal to 5 centimeter. Okay, now see properly. Angle D, then this side and this angle. Two angles are given, and one side, that is the including side of these two angles. That is, this side contains these two angles. Okay, now this should strike in your mind that we can think of ASA, that is two angles and the including side. So here also what information you have: angle, side and angle, angle, side and angle. So you can think of angle, side, angle in this case. Okay, angle D is equal to angle Q is equal to 60 degree. Okay, then this DF is equal to QR. Okay, then angle F is equal to angle R is equal to 80 degree. Now we have one pair of angles equal, then we have one pair of sides equal, and that's really very important to note that the pair of sides that is equal is actually the including sides of these two angles. And then we have another pair of angles equal, that is angle F is equal to angle R. Therefore angle, side, that is the including side, it's really very important, and then again angle, angle and the including side, ASA is being satisfied. Angle, side, the including side, and this angle 80 degree. So ASA is being satisfied. Therefore yes, these two triangles, that is triangle DEF and triangle PQR, are congruent, and therefore by ASA they are congruent. Let's move to the second part, that is B part. Let me remove this. Okay, quickly remove this. Okay, in this case angle D is 60 degree, angle F is again 80 degree, and DF is 6 centimeter. Angle Q is 60 degree, angle R is 80 degree, QP is 6 centimeter. Now it's really very important that this QP is actually not the including side of these two angles. 60 degree and 80 degree have one including side, and that is QR. But in this case you have QP. Okay, and that's really very important point. So you can see here, one will say that hey, this angle D is equal to angle Q. Yes, you will say that one pair of angles satisfied. Yes, then you will say that side DF is equal to side QP. Yes, it's equal. And then you have angle F is equal to angle R. Someone will say that ASA is being satisfied. No, it's not being satisfied. Why? Because yes, this DF is the including side of 60 degree and 80 degree, but this QP is not the including side of this 60 and this 80 degree. Yes, these two pairs of angles are equal, but in this case we don't have any information of this QR. We don't have any other information of this QR. Now someone will say that, hey, you know what, we can calculate actually this angle. This angle will be what, 40 degree. How? By angle sum property. The sum of the angles of a triangle is 180 degree. Therefore, if you will calculate from this one, this will come 40 degree. This will also come 40 degree. But it's useless information, because yes, this angle will be equal to this one, that is angle E will be equal to angle P, and this angle Q will be equal to angle D. But then we don't have any information of this side, right? So in any case, you cannot get an including value of an including side. ASA property is not being satisfied, since only this, from this information what has been given to us, we cannot say that these two triangles are congruent, because only this information, limited information, has been given to us. Ray AZ, or in fact, okay, I have wrongly written it as R, but should be Z, bisects angle DAB. Angle DAB, it means that this angle, angle 1 and angle 2 will be equal. This is the angle bisector. As well as angle DCB, angle DCB, angle bisector, it means that this angle, angle 3, will be equal to angle 4. Okay. State the three pairs of equal parts in triangles BAC and triangle DA and triangle DAC. BAC and DAC, you have to state three pairs of equal parts. Okay. So you can think of this figure as something like this. Quickly draw it like this. You can think of it like this. I have separated these two triangles for your convenience to understand it properly. ADC and ACB. I have just separated these two triangles. Okay. Now angle 1 is equal to angle 2. Angle, that is angle DAC is equal to angle BAC. Then you have this AC as a common side, right? This AC, if you see here, is actually the common side. It's common to both these two triangles, that is this side, right? Therefore side AC is equal to side AC, that is the common side. And then you have this angle, angle 3 is equal to angle 4, that is angle DCA. DCA is equal to angle BCA, right? Okay, so these are the three pairs of equal parts in these two triangles ADC and BAC. The first part is this one. Okay, is triangle BAC congruent to triangle DAC? Very interesting thing. Now, from these 3 points, can we see here that actually this angle 1 and angle 2 are equal. This is the common side, and this angle 3 and angle 4 are equal. This AC is actually common, and this AC is the including side of angle 1 and angle 3 and angle 2 and angle 4, right? In this one, AC is the common including side of 1 and 3. In this triangle, AC is the including side of 2 and 4, angle 2 and angle 4. And from these three, we can say that angle, side, angle, two angles and the including side. That's really very important. The including side of these two angles. So ASA property is being satisfied. Yes, if ASA property is being satisfied, these two triangles will be equal. Now, the third part, is AB is equal to AD? It's asking that is AB is equal to AD. Now, from these two triangles, if we see here, this A, since this is common here, right? This vertex is common. So we'll say that from these two triangles, A and A are corresponding vertices. From here, C is common. C is common. So from this one, you will say that these two are corresponding vertices. Therefore, yes, D and B are corresponding vertices. Right. Okay. And why it's important? It's important because we now know that, yes, these two triangles are congruent. Therefore, since these two are congruent, we can say that AD is equal to AB because congruent triangles are of same size and shape. Side AD and side AB, these are actually corresponding sides of these two congruent triangles. These are corresponding sides, and the corresponding sides are always equal. Therefore, yes, they will be equal. Similarly, is BC is equal to CD? Yes, of course, BC will be equal to CD because it's another pair of corresponding sides. Side CD and side BC, these are pair of corresponding sides, and since these two triangles are equal, therefore, yes, these two sides will also be equal.